Hey, algebra, how's it going? It is week 8. It is the first lesson. It is lesson 8.1. Okay, so last week we covered multiplying polynomials and kind of simplifying polynomials as well, right? Multiplying through, seeing what linear factors, once we factored out a polynomial, what would cancel. Today we're going to look at adding. So we're just starting with the very basic stuff. We multiplied, those are not too bad. Now we're going to start adding. So I typed up some steps as I usually do for adding rational equations. Basically, we're going to treat them, again, when we think rational equations, I'm thinking like fractions. So we're going to treat them the same way we do fraction operations, all right? So my first step would be to get a common denominator, all right? So when we multiplied, we just multiplied straight across. But when we add fractions, you have to make sure you have the common denominator in order to add right across, all right? Once you have a common denominator, then you're just going to add like fractions, all right? So you're going to keep the denominator the same, and just add the numerators. And then step 3, of course, as mathematicians, we love to simplify as much as you can, make it easy on yourself, all right? So I'm just going to show like 2 different ways to do these, some basic ones and leading in with a rational equation, and then a little bit more harder one, and then leading in with a rational equation. So look at this first example, all right? Step 1, I'm just looking at this fraction one. Step 1 would be get a common denominator. Well, that's already done, right? I have the same denominator of 8 in both fractions. My second step would be to add just like regular fractions. So same thing you've done since when did you add fractions? That was a long time ago. You've done it forever. Keep the same denominator, 8, and then just add the numerator. So this is really 3 plus 4 over 8, which is just 7 over 8. All right, that was not too bad. Again, I just want to show you these basic ones, all right? Let's look at how we would do this with a rational equation. Step 1, get a common denominator. Is the denominator in both of these parts the same? Yes, it is. There's x plus 4 over here, and there's x plus 4 over here. Therefore, these two have common denominators. Now we can just add like regular fractions. So when we add like fractions, you keep the bottom the same, x minus 4, and then you just add the top. So the top is going to be x plus 4 plus 2x minus 16, all right? Again, that comes from our numerators in our fractions up here, all right? And then we can just continue to simplify. So on the top, let's combine like terms. I have an x and I have a 2x, so I'm going to combine those and just be 3x. And then my constants here, I have a 4 and a negative 16. Adding those is going to give you minus 12, all right? So the top just simplifies down to 3x minus 12. Again, we keep that denominator the same, x minus 4. And then I say, can you cancel anything at all? Just make it, simplify it down as much as you can. I see right now that on the top, I can factor out a 3 from both the 3x and the negative 12. Because again, 3 goes into 3x and 3 goes into negative 12. So I'm just going to simplify this down to, I'm going to factor out a 3, and that's going to leave me with x minus 4 divided by x minus 4, all right? So the top is 3 times x minus 4 divided by x minus 4. And then you can say, oh my goodness, I've got an x minus 4 on the top and the bottom, right? I have a factor of x minus 4 on the top and the bottom. Those can just cancel out, and really, I just have 3, okay? Again, if you remember from last week, since we've canceled out something, you have to make sure that you're accounting for what's in the denominator, because we cannot divide by 0 in the denominator. So if I take my denominator of x minus 4, and if I set that equal to 0 and solve for x by adding 4 to both sides, I get x equals positive 4. So really this thing simplifies down to 3, and this is technically, if you want to think about it, it's actually like a straight line, but we cannot have, x cannot be equal to 4. So wherever in our line, wherever in our line x would be equal to 4, we would have a hole in that graph, all right? So Basically, I really want to see that you can get here and simplify as much as possible, all right? So that was a very quick equation where you just had the same denominator and you added straight across. Let's look at what would happen if you have something with the not same denominator. I'm going to scoot this down so we're just focusing on the regular fraction part. Okay. So now we have fractions and they don't have a common denominator. So how do you get common denominators? I like to just like multiply by the other denominator in the other fraction, right? So instead of 2/7 and 1/2, I'm going to I know that my lowest common multiple of 7, 2 is going to be 14. And that was just because I multiplied 7 times 2. And here I just multiplied 2 times 7, right? So I just multiplied each side by each other. But again, you have to multiply the top and the bottom, right? Because otherwise we would be changing the actual numbers itself. So what I'm going to do is I'm going to take 2/7 and I'm going to multiply by, I'm going to use this, I'm going to multiply by 2 over 2 on the top and the bottom, okay? 2 over 2 is just equal to 1, so it's really just like I'm multiplying by 1, right? And when I multiply by 1, nothing really changes. So I'm kind of allowed to do this. It's all right. In the other fraction, all right, so I'm going to highlight that. That was getting a common denominator for this part. What about this other part of 1/2? Well, just like we said, I'm just going to multiply by 7 over 7. So this is going to be 1 over 2 multiplied by 7 over 7. Again, 7 over 7 is just 1, so it's not really doing anything if I just multiply by 1, so I'm okay to do that. All right, and then we can just start multiplying these through. So this first part here is going to simplify down to 4 over 14. Again, all I did was just multiply those fractions straight across, and then I have plus, and then multiplying these fractions straight across, I get 7 over 14. Now I have a common denominator of 14 in both fractions. Now I can just add like regular fractions, and that's going to give me 11 over 14. Okay, so that's how we do it with just our regular numbers. Now let's look at it with some equations. All right, I gotta scoot these all down. Okay, so this one here, it's a rational equation. Step 1, do I have common denominators? No, I don't. All right, so to get common denominators, just like what we talked about, I'm going to multiply this first term by the denominator over here, right? So I have a denominator of x minus 1. So I'm going to multiply this first term by x minus 1 over x minus 1. Again, here, that fraction is just 1, right? I'm just multiplying by 1, so it's not going to change anything. But it is going to change that denominator so that we have a common denominator in both of these terms. What do I have to do to this second fraction to get a common denominator? Well, I need to multiply it by x plus 2 over x plus 2. So I'm going to multiply this second term by x plus 2 over x plus 2. Again, this is just multiplying. I'm just going to write this out. Multiplying by 1, right? We're multiplying by 1, but it's just like a fancier way. So all of this is going to boil down to, I'm just going to write it out step by step, 1 over x plus 2 times x minus 1 over x minus 1. Let me get that parenthesis a little bit bigger. Just like what we planned over here, all right? And then the other term is going to be plus 3 over x minus 1 times x plus 2 over x plus 2. I keep putting parentheses on the end there. All right, so now that we've multiplied, this is going to give us like terms. So now I can just multiply these through here. All right, this is still like step 1, getting my common denominator. So I'm going to focus on this first half. Multiplying straight through, all right? My numerators here, it's 1 times x minus 1. So that is going to give me, move this over, 1 times x minus 1 is just x minus 1. Divided by what's on the bottom if we multiply straight through. We can just say that is x plus 2 times x minus 1. X plus 2 times x minus 1. All right, so that's that first term simplified down. And then let's focus on multiplying the second term. Okay, so now we have plus. What would all of this simplified down to, multiplied out, be? Again, we're just going to take it simply and multiply straight across. So that is going to give us 3 times x plus 2 plus 3 times x plus 2 divided by what's on the bottom? X minus 1 times x plus 2. X minus 1 times x plus 2. Okay, so I'm going to just kind of point and arrow of where we were going. So now we are here. All right, now we are here. Do we have common denominators? Yes, we do. And that's what we planned, right? Over on the left-hand side, I have x plus 2 times x minus 1. Over here, I have x minus 1 times x plus 2. Even though they're kind of flip-flopped the order of them, it's still the same because it's just multiplying, right? So step 1 is done. I do have common denominators. Now what I can do is just add like regular fractions. When you add like regular fractions, you keep the same denominator. So I'm going to keep the same denominator of x plus 2 times x minus 1. And then you add the top. So the top is going to be x minus 1 plus 3 times x plus 2. And now we can simplify as much as possible. So I'm going to go down below here. So simplifying the top, what if let's just distribute that 3 to both of these terms in the parentheses. So that's going to give me x minus 1 plus 3x plus 6 after distributing, still over x plus 2 times x minus 1. And now we can finish combining our like terms in the numerator. So I have an x and a positive 3x. Those are going to combine down to 4x. I also have a negative 1 and a 6. So that is going to be a positive 5. There we go. And then dividing here, that's going to give me, again, that numerator is just still the same. All right. And then there we go. Fantastic. All right. And you can just leave it there. We could analyze and say, oh, look at, I'm going to have some probably vertical asymptotes from the bottom, but I'm okay. I just really am concerned that you can get to this step. All right. Finding common denominators, adding them, simplifying as much as you possibly can. So it looks a little bit nicer than this, right? Okay. I have one last example. Where is it? Here it is. Same kind of deal. Again, these are more simpler ones. This is what I will give you on the assignment. I'll ask you to do maybe 1 or 2 of these, or 2 or 3 of these. So, first step, do I have common denominator? No, I do not. Let's make sure we can get a common denominator out of this. So, again, to get a common denominator, I'm just going to multiply like the x plus 5 and the x minus 3 together, right? Just like what we did. So on this first term, I'm going to need to multiply by x minus 3 over x minus 3. Again, you're just taking the denominator from the other side and like kind of duplicating it and multiplying it by the first term, all right? So I'm going to get rid of that highlighting. And for this second term, I'm going to multiply by, well, what's the denominator over here? It's x minus 5. So I'm going to multiply by it's x plus 5. I'm going to multiply by x plus 5 over x plus 5. All right, so here, multiply. All right, so that is going to turn into, my first term is 2 over x plus 5 multiplied by, what did we plan? The x minus 3 over the x minus 3 plus, and then over here I have, what's that term? It's 4 over x minus 3. And that term is being multiplied by x plus 5 over x plus 5. And then we can simplify, all right? So before I can add both of these, again, we're just going to have to multiply straight through. So if I focus on this first term, all right, if I focus on this first term, I'm going to multiply that fraction. So the top is 2 times x minus 3. The denominator, all right, the the denominator, multiplying those terms together is just x plus 5 times x minus 3. All right, we're just going to keep this very simple. All right, you can just literally write those factors next to each other, right? Show multiplication. So that was that first term. Plus, now let's multiply the second term, all right? The second term, so our numerator is 4 times x plus 5 divided by, and if we multiply through the denominator, we have x minus 3 times x plus 5. Now I can check and say, do I have common denominators yet? Yes, I do. In both of these fractions, I have a x minus 3 times x plus 5, or I have x plus 5 times x minus 3. Again, they're the same thing, even though they just have a different order. These are still what we consider common denominators. So now I can just add these just like fractions. Again, when you add just like fractions, you add straight across the numerator, but you have to keep the same denominator. So adding straight across from the numerator, I'm going to get, again, I'm just going to write this all very step out, step out. Okay, so that's adding straight from the numerator, it's 2 times x minus 3 plus the numerator in the other term, 4 times x plus 5, being divided by, again, what was our common denominator? X plus 5 times x minus 3. And then we can simplify as much as we can. What do you think about, let's distribute this 2 to both of these terms, and let's distribute the 4 to both of these terms, all right? So distributing the 2 in that first part, that's going to give us 2x minus 6 plus distributing the 4 in both of these terms is going to give us 4x plus 20. And we didn't do anything with the numerator or with the denominator, so I'm going to keep the same denominator of x plus 5 times x minus 3. And then we can just simplify our like terms up top. So I have 2x plus 4x. Those are like terms in my numerator, so that's going to add and be 6x. I have negative 6 and positive 20, so adding those together is going to give me a positive 14. Still divided by x plus 5 times x minus 3. And you can just leave it here, all right? That's totally fine as well. So simplifying down to something that looks a little bit nicer is fine. Okay, not too bad. Again, get a common denominator, all right? Add just like fractions. Keep the denominator the same, add your numerators, and then simplify as much as you can. Maybe simplifying is you have to distribute a number in the numerator, right? Or maybe it is combining the like terms like what we did here. All right, simplify as much as you can. Have a great day, you guys, and enjoy your week. You guys are doing so good. If you're here with me this far, you're at week 8. Keep rocking it. Keep going. Let me know if you have any questions. I appreciate you, and have a great week.